Okay, lesson 4, jet streams. These are cool. I like these. Well, I like the whole module, but I particularly like these. Okay, in your module booklet, you have got a whole page of text. In the 2020 version of the module, it's page 11. In other years, it may well be different, but page 11 for this year. Okay, I think we should probably start off by saying, why are they called jet streams? And that's a perfectly logical answer because they are used by jets, jumbo jets, aeroplanes, and that's where they get their name from. So before we talk about what they are and why they have significance for weather and climate, let's just talk about that element. If you have ever flown across the Atlantic to North America and back again, you may well have noticed that your return journey was about an hour quicker on average, and that's because of the jet stream. And also I've included a couple of screenshots of some news stories from recent years. So a British Airways plane got back from New York to Heathrow in 5 hours 16 minutes. It's usually about 7 hours, so that's really impressive. And then a Virgin Atlantic flight actually travelled at 801 miles an hour and arrived 48 minutes early. You get the idea. Jet streams are used by planes to go faster, but also to use less fuel, which is really good for climate change, carbon cycle, greenhouse gases, all of that kind of stuff. So they're called jet streams because they're used by planes. Just a little bit of history for those of you that might be interested. They were actually discovered in the wars, slightly in World War I with the use of Zeppelins, but much more so in World War II, when pilots who were travelling across the Atlantic discovered that their return journey was often quicker, and that led to the discovery of these things. Okay, cut long story short, it's a lot to do with aeroplanes, ladies and gents, but what on earth are they? Okay, so I'm taking you back to your model of atmospheric circulation, your tricellular model, whichever name you want to give it. And these are at the top of the troposphere. In lesson 1, we were talking about how the atmosphere is a layer of gases, but we divide it into 5 layers. And the one that we live in, the one that all the weather and climate happens in, is called the troposphere. These jet streams are right at the top of the troposphere, okay? And they are between the cells. So here's the Hadley cell, the one closest to the equator, and we have a jet stream between the Hadley and Ferrel, and then we have another jet stream between the Ferrel and Polar. So that's where they are. And in fact, sorry to keep scrolling through, but these diagrams, which we were using to explain the shifting of this in the seasons, you can see, look, the jet streams were marked on. I didn't make any reference to them at the time because we were already doing lots and lots of stuff, but there they are. So they occur between the cells for reasons that I will talk to you about in a minute. If you look on a map view, then they occur like that. Here is the ITCZ in the middle, so this would be your 2 Hadley cells, Ferrel, Ferrel, Polar, Polar. So look, the jet streams occur between the Hadley and Ferrel cells and between the Ferrel and Polar cells. However you want to draw or remember that, that's absolutely fine. But that's where they are. What are they? Okay, they are described as rivers of air, flows of air, currents of air. You can go with any of those 3 descriptions that you like, but very much like ocean currents, which we will go on to talk about in a couple of videos' time, they are movements of air, okay? And in the same way that animals use ocean currents to migrate around the planet, made very famous, of course, by Finding Nemo, these are used by aeroplanes to travel around the planet. So they are flows or movements of air. They're at the top of the troposphere, so they're about 10 kilometres up in the air, and they occur between the cells. They travel very, very fast, which we've already alluded to here. They travel, you know, sometimes at 800 miles an hour, 700, 300. They are incredibly fast movements of air. Why do they exist? Well, we don't really need to know much about this, but you may have the sort of brain that wants to know, and that actually helps you learn stuff if you understand it. So they are there because of temperature differences. The Hadley cell is closest to the equator, so it's quite hot. The Ferrel cell is a bit cooler. There is a temperature difference, hence we get a jet stream. The polar cell is cold, the Ferrel cell is warmer. There is a temperature difference, hence we get a jet stream. And that is all fully explained in the module booklet, so you can have a look at that. But we're doing weather and climate. We're not particularly interested in aeroplanes. So we need to know about the link between jet streams and what that means for the module. So the first thing that you need to know is that jet streams can only go in one direction that I'm trying to show with that arrow at the bottom of the screen. They go from west to east. They go in an easterly direction. Obviously, we wouldn't say from left to right because we are geographers, but they only go in one direction. And that has significance for what we're going to talk about next. Okay, so they only go in one direction. I've included some hyperlinks there that you can have a look at. There's a nice explanation from a BBC weather forecaster. Then there is a slightly more academic explanation by the Met Office, and then there is a little news story as to how it links to the weather. But time for some fairly horrific diagrams. Okay, the egg timer triangle type thing is my attempt at a map of the UK. It is terrible, I know that. The red line is my attempt at the jet stream. So what you want is you want three little simple maps of the UK, and you want one in which the jet stream is north, one in which it is south, and one of which where it's bang over the UK. I have made the jet stream narrower than it really is, but just for the purposes of the diagram. Okay, so let's just go back. We live near this one, the polar jet stream, because we are about 60 degrees north of the equator, which is where the polar cell and the Ferrel cell meet. We know already that that's an area of low pressure, and we now know that there is a jet stream there. The jet stream can only go that way. Okay. So, if the jet stream is north of us, that means that the polar cell is up here and the Ferrel cell is down here. And actually what some students do is they do a little bit of colouring in. So they colour this side of the jet stream in a blue to signify that it's cold, and they colour this side of the jet stream in like a pinky orangey colour to signify warm. If the jet stream is north of us, our weather shouldn't be too bad, because the bit where the polar cell and the Ferrel cell meet, the low pressure area where the air is rising, is north of us. So we should be in quite a nice high pressure area, and hey presto, it should be quite nice because we're in the Ferrel cell. And this is typically what we expect in the summer for the UK, which, let's begin to link things together. This might tax your brain a little bit. This makes sense, doesn't it? Because the sun moves north in June to be over the Tropic of Cancer. That's our longest day, the summer solstice. It's also the beginning of our summer, and because the sun and the ITCZ shift north, the whole model shifts north. Hey presto, where the Ferrel cell and polar cell meet will be north of the UK. It kind of explains why we have slightly nicer weather in the summer. Brilliant. Right, this one. Jet stream is south of the UK. So we are now in the polar cell. You'd expect the weather to be colder. You would also say it might not be too bad because the jet stream would be now over kind of northern France, those sorts of places. And so maybe the south of England might be getting some pretty rubbish weather, but certainly towards the north, it shouldn't be too bad. It will be cold because you're in the polar cell. Again, this kind of makes sense, doesn't it? Because in December, which is our shortest day, which we call the winter solstice, we know that the sun is taking most of its energy to the southern hemisphere, which is why if you were celebrating Christmas in Australia, you'd have a barbecue or go to the beach, that sort of thing. And that would make sense that the polar cell and the feral cell have shifted south, wouldn't it? It does begin to all link together. The third situation is the one that we worry about. If the jet stream is right over the UK, and it could be up here, it could be here, but you want, well, no, you don't. But if the jet stream is right over the UK, I was going to say if you you want it to be, you don't actually. The jet stream I call a conveyor belt of bad weather because, ladies and gents, wherever the jet stream is, that's telling you it's where the polar cell and feral cell are meeting. Wherever the polar and feral cell meet is an area of low pressure, which is bad weather. And what the jet stream does is it has a tendency to exaggerate that bad weather. And therefore, if the jet stream is bang over the UK, you would expect the weather at that time to be pretty horrible. The last time that the jet stream got stuck over the UK for any prolonged period of time was the winter of 2013/14. Now that was the winter that we lost the railway line at Dawlish, the Somerset Levels flooded, the coastline of the southwest changed on a semi-permanent basis. We had storm after storm after storm, and guess what, ladies and gents? It's all because the jet stream kind of got stuck over us. Now I'm going to open this so that we can have a see. Today is the 14th of December 2020, as you can see on here. Aha, okay, so on this map you can probably figure out for yourself, this is the jet stream. So the jet stream currently is over the UK, it's really over the south of the UK, and this morning I did the school run and it was windy and it was rainy and it wasn't very nice at all, which perfectly fits with the weather that I would expect from the jet being here. And if I click it forward, yeah, so we're going to have bad weather for the next couple of days. Now, that's Tuesday afternoon, should be okay. And then it comes back. Oh, crikey. Okay, so all I'm trying to show you is that my terrible diagram is trying to represent something that does really happen, and weather forecasters will pay a huge amount of attention to the location and the speed of the jet because it has a profound impact on our weather. Just to pick up on this arrow once again, when we get to the UK climate, which will be in a later video, we will be talking about how the west of the UK is wetter than the east. And there are two reasons for that, but one of the reasons is because of the direction of jet streams. If the jet stream can only go that way, and the jet stream is a conveyor belt of bad weather, the bad weather is always going to hit the west of the UK first, and we therefore receive the brunt of it. Now, the wiggliness. You need to know that it's called a Rossby wave after a scientist called Carl Gustav Rossby. Isn't that just the best name ever? Sometimes the jet stream is relatively flat and sometimes it's really wiggly. And these wiggles are known as Rossby waves. Now, for A-level geography, you do not need to get too obsessed with this. This would be when the jet stream was really fast, and this would actually slow it down quite a lot. But essentially, the more wavy it is, the more kind of crazy the weather gets, really. That's my very basic interpretation. But in your module booklet, whatever year it is that you are watching this video, there will be a GeoFile article called The Interaction of Jet Streams and Ground Weather Patterns. And if you're one of these people who would like to fully understand jet streams, Rossby waves and all of that, that is a fantastic article for you. If you just would like the bare minimum to scrape through, then you need to know about why they're called jet streams, where you find them, the fact they can only go in one direction, and the fact that they do have a profound impact on our weather. Underneath the jet stream will be low pressure and bad weather. Okay. So that's that one.